No, sir.
Okay, just write it down to this. Done?
Yes, sir.
Okay, related to this formula, if you have to calculate or define a scale like Celsius, Kelvin, Fahrenheit, or any different scale, so it will be temperature on the scale. Let's say in Kelvin, it will be K minus 273 divided by 373 minus 273 equals to, in terms of Fahrenheit, it will be F minus 32 divided by 212 minus 32. In terms of Celsius, it will be C minus 0 divided by 100 minus 0. In terms of resistance offered by platinum wire, resistance at some temperature C, resistance at 0 degrees Celsius, 100 degrees Celsius, 0 degrees Celsius. Similarly, it would be in terms of length of mercury column at some temperature C, length at 0, divide by length at 100 minus length at 0, and so on. So just use this particular relation and you can define formula for any different scale. Hamza, any doubt?
No, sir.
Now, related to this part, you will be asked, find the numerical value at which Kelvin and Fahrenheit numerically equal. Find temperature at which Kelvin equals to Fahrenheit. Similarly, Fahrenheit equals to Celsius. Just put the value of K and F in the above expression as X and equate them to find X. Similarly, if you have to calculate F equals to C, put the value of F and C to be Y and equate them, you will get Y. Just write it down and try to solve. Hamza, any problem while solving?
Sir, we have to use the above formula, right?
Yeah. Let's say for first part, put the value of k to be x minus 273 divide by 373 minus 273 equals to, similarly for f, x minus 32 divided by 212 minus 32. You'll get the x on solving. Similarly for second part, put the value of f to be y, divide by 212 minus 32. And also for c, take it as y and simplify it. Just try to solve. I'm just coming in 1 minute. Yes, you got any answer? Hamza, you have solved the first part?
I am stuck, sir.
Okay, let me solve. I think second one is easier. Okay, let me solve first. X minus 273 divided by 373 minus 273, it will be 100. X minus 32 divided by 212 minus 32, 180. So this and this will cancel out. Just cross multiply 18x minus 18 into 273 equals to 10x minus 320. So move this 10x to left side and rest of the term to right side. So 18x minus 10x will be 18 into 273 minus 320. Hamza, is it clear up to this part?
Yes, sir.
So 18 minus 10, it will be 8x. Just multiply it. 18 into 3, 54. 18 into 7, 126 into 5, 131. 18 into 2, 36 plus 13. It will be 49 minus 320. Now subtract it. 4 minus 0, 4. 11 minus 2, 9. 9 minus 8 minus 3, 5. 4. Divided by 8 equals to x. So 8 into 5, 40. 5, 9. 8 into 7, 56. 3, 4. 8 into 4, 32.25. So this will be a value for Kelvin and Fahrenheit to be coinciding. Is it clear?
Yes, sir.
Salman, any doubt? Similarly, if you try for the second part, y minus 32 divided by 180 equals to y minus 0 divided by 100 minus 0. So 0 and 0 will cancel out. Just cross multiply. 10y minus 320 equals to 18y. So 10y minus 18y equals to 320 minus 8y equals to 320, y equals to minus 40. Is it clear?
Yes, sir. I'm done, sir.
Now there will be question. Salman, done? You'll be asked, suppose if there exists a faulty thermometer reads ice point as 5 degrees Celsius and steam point as 95 degrees Celsius. Find a reading of 60 degrees Celsius on this scale. In this part, we have two different thermometers. One is any faulty thermometer, which having some error in its reading, and the other is Celsius scale. So for faulty part, just write F minus its LFP, lower fixed point, that is 5, upper fixed point 95, lower fixed point 5. For Celsius, write C minus 0 divide by 100 minus 0. Now put the value of C to be 60 degree and just equate them to find the value of F. Hamza, is it clear?
Yes, sir.
Try to solve. Good, Khalid. Hamza, any problem while solving?
No, sir. Almost clear.
Okay. Hamza, you have done a little mistake while solving. Let me solve F minus 5. 95 minus 5 will be 90. C is 60 divided by 100. So this 0 and this 0 will cancel out. Move this 90 to right side. So F minus 5 equals to 6 into 90 divided by 10. This 0 and this 0 will cancel out. So 9 into 6 will be
45, 54.
Okay, so it will be 54. Move this 5 to right side. So it will become plus. So on adding, you will get 59 degree. Is it clear?
Yes, sir.
Salman, any doubt?
No, sir. No doubt.
Done, sir.
Okay, so this is all introductory part of this particular chapter. Next is thermal expansion. Why do solid expand on heating? Suppose at some initial temperature, separation of particle will be this. At temperature T0. So what will happen to its separation on increasing temperature? Khalid,
Yes, sir.
what will happen on increasing temperature to its separation?
Sir, it will get closer to each other, the
Get
particles.
closer or get far away from each other?
Uh, I think far away from each other.
Let's say on increasing temperature, thermal kinetic energy of particle will get increased, and due to which there will be decrease in strength of their bond. So particle will tend to go far apart from each other. So separation between particle will get increased like this. So it will be at some other temperature T. So what is happening? So you'll say it will expand on heating. Why it will expand? Since on increasing temperature, thermal kinetic energy of particle increases. So it will tend to vibrate more, and hence bond gets weakened, hence separation between particle increases. Hamza, is it clear?
Yes, sir.
So on increasing temperature, thermal kinetic energy of particle increases. So bond get weakened due to which separation between them increases. Hence, solid get expand on heating. Now, if you have to calculate how much would be change its dimension according to length, area, volume. So let me define you first along length. So it will be linear expansion of solid. To define this particular linear expansion, we define a term that is alpha, which is called temperature coefficient of linear expansion. Suppose you have a rod of length L0 at some initial temperature T0. So what will happen on increasing its temperature? Length will increase up to this point. It means it will become L at some temperature T. So there is change in length from this point to this point, let's say delta L. So this alpha simply defines you at what rate the length of a particular rod will increase or decrease with respect to change in temperature. So first write it down, then I'm defining this alpha. Yes, Khalid, do you want to ask something? Salman, written?
Yes, sir.
So alpha is delta L divided by L naught times delta T. This particular quantity is nothing but fractional change in length. And this quantity, change in temperature. So we can say alpha is ratio of fractional change in length to the change in temperature. So it is the ratio of fractional change in length to the change in temperature. it simply defines at what rate length will increase or decrease with respect to change in temperature. Hamza, is it clear?
Yes, sir.
So according to this formula, SI unit of alpha will be Kelvin inverse or degree Celsius inverse. So if you expand this relation as alpha equals to delta L by L naught times delta T, just cross multiply. So alpha times L naught delta T equals to delta L. We may write delta L as L minus L naught equals to alpha L naught times delta T. Move this L naught to right side. So L naught alpha times L naught delta T. Take out L naught as common. So you'll get 1 plus alpha delta T equals to L. So this will be your final expression of calculating length at any change in temperature delta T. Is it clear?
Yes, sir.
Okay, just write it down.